Write down the letters that you see here. Here's a hint. The objects the letters are made of are all fridge magnets. And the word that we want is magnets. Related words are magnetic, magnetism, magnetized, and magnetism is one of the forces of nature, along with electricity and gravity. Let's explore magnetism with a little bit of history. Magnets have been in use for a long time by the Vikings, the Chinese, using a type of compass to navigate by. This rock is a type of magnetite or lodestone which has a permanent magnetic field. Magnets are mainly ferrous materials, not ferrule, ferrous, like iron and steel, but modern magnets, like this horseshoe magnet, are made of alnico, a combination of aluminium, nickel, and cobalt. Magnets can be found in many shapes and sizes and can be found everywhere, in motors, disk drives, tape cassettes, tools, pickups, not trucks, pickups for guitars, and in scrapyards. This is all good to know, but what exactly is magnetism? How does it work? In a magnetized object, everything that it is made of, the domains, are lined up the same way. Unmagnetized objects are random. The domains are atoms, the basic building blocks of the universe. Atoms are made of particles and can be joined together to form molecules. And molecules form into three states of matter: gas, liquid, and solid. Iron is a solid. It's a ferrous material that can be easily magnetized. This is a bar magnet with its magnetic field being shown by the alignment of iron filings. Every magnet has two poles, north and south. Opposite poles attract. Same poles repel or push apart. You can explore this using small disc magnets. The side of one disc has a dimple indicating north. It will push away from the other magnet with the same pole coming towards it. It may even flip over to its opposite pole and suddenly become attracted to it. The magnets in this test tube have the same poles facing each other. As they cannot flip over, the top one seems to be floating in midair, levitating. Try this interesting project, the levitating paperclip. The magnet is attached to a top plate, a paperclip is tied with a string stuck to the magnet, and the line or string is thread through a clip and stuck at the bottom of the plate. You pull on the string, it is shortened and gradually releases itself away from the magnetic field, and gravity takes over. Here's a science application. Measure how far away the paperclip can be before it escapes the magnetic field. Attach more paperclips to see how heavy they can be to pull away from the magnetic field. This nail is not magnetic. You can magnetize it by rubbing it along in one direction on a strong magnet. Not very strong at all. So try rubbing quite a few more times. And yes, we have a new magnet with a strong magnetic field and a slightly cleaner nail. Magnets can also be made using electricity. This nail is tightly wrapped along its length with insulated wire. Each end of the wire is connected to a battery, one end to positive, the other to negative. This is an electromagnet. The most astounding thing about magnetism for me is that the Earth has one gigantic magnetic field. This is why a compass works. I hope you have had fun learning about magnetism.